Okay, let's jump right into a classic debate, one that's been around for decades. You've got the rigorous scientist on one side and the hands-on change agent on the other. For a long, long time, these two ways of understanding the world have been painted as total opposites. But what if that whole conflict is just built on a massive misunderstanding?
So that's really our central question here. In one corner, you have the scientific method, the engine behind centuries of incredible discovery. And in the other corner, you have action research, which is designed not just to study the world, but to actually get in there and change it. So are they really enemies, or could they actually work together?
You know the conventional wisdom, right? It neatly separates them into two completely different worlds. Science, that's for the pristine, controlled lab. Action research, that's for the messy, unpredictable real world. One is searching for universal truth, the other is just trying to solve a specific problem. It's a very clean division, but maybe, just maybe, it's a little too simple.
And these are the stereotypes that go along with it. The scientist is this detached, objective observer, searching for big, universal laws. And the action researcher, well, they're embedded, they're collaborative, and they're focused on solving one problem right here, right now. This whole view just sets them up to be complete opposites. But are they, really?
To figure that out, let's properly meet our two contenders. Let's try to see them not as rivals, but just as structured processes for figuring things out, for generating knowledge. And you'll see, they both have a really logical flow, even if they look pretty different on the surface.
First up, the classic, the scientific method. You start by stating a problem, you form a hypothesis, an educated guess, and then you deduce a prediction you can actually test. Now, here's the crucial final step, the one a lot of people miss. The goal isn't to prove your hypothesis, it's to try and falsify it. You're trying to break it. Because if it survives all your attempts to break it, it gets stronger. It's a very linear path to knowledge.
And now, let's look at action research. See the difference? It's not a straight line, it's a cycle. You systematically analyze what's going on, you plan an action, you do it, and then, and this is the key part, you evaluate the results. All that learning feeds directly back into the next cycle. It creates this continuous loop of doing, learning, and improving.
So we have two pretty distinct processes. And for years, critics have pointed to these three supposedly unbridgeable gaps that separate them. These are really the core arguments for why you supposedly can't apply scientific rigor to messy, real-world problems.
And here they are, the three big myths that create this whole divide. The first is that science is just too simple for real-world cause and effect. The second is that scientific control groups are basically impossible out in the field. And the third is that the two methods are just locked in this eternal battle of data, numbers versus stories. All right, it is time to bridge that gap. Because as our source material shows, these so-called discrepancies, well, they're actually based on really outdated or incomplete ideas of what the scientific method can actually do. So we're going to tackle each one of these myths one by one.
Let's start with myth number 1, causality. The argument goes something like this. Organizations are these incredibly complex systems, right? Everything affects everything else. So trying to isolate one single cause for one single effect is like trying to understand the entire ocean by just studying a single drop of water. It completely misses the big picture.
But that's a caricature of science from 100 years ago. Modern science totally embraces the idea that any given effect has multiple causes. It doesn't shy away from complexity. It has developed incredibly powerful tools specifically to model and understand it.
In fact, modern science has this whole toolbox of statistical methods just for this. They let researchers analyze a whole bunch of outcomes at the same time, find hidden patterns in the data, and even test really complex models of cause and effect over time. These are exactly the kinds of tools you need to understand a complex organization. So this idea that science can't handle complexity? Yeah, myth busted.
Okay, on to myth number 2, control groups. In a lab, it's pretty easy to give one group a treatment and a control group nothing. But in an office, can you imagine? If one team gets this cool new training program and the other team gets told, sorry, you get nothing, you're going to create a lot of resentment, and that can poison the whole project.
But this kind of misunderstands the basic principle. The goal isn't to deprive people, the goal is comparison. And field scientists have this really clever solution. It's called a placebo control. This group gets a different but still positive intervention. That way, everybody gets something, you avoid the resentment, and you still get a valid scientific comparison. Pretty smart.
And finally, we've got myth number 3, the great data divide. The idea that science is all about cold, hard, quantitative data. And action research, that's about rich, deep, qualitative stories. Numbers versus narratives. Objective versus subjective. This is honestly one of the most persistent stereotypes out there.
In reality, this is a totally false choice. Good research, any good research, uses whatever data it needs to get the full picture. If you rely on only one type of data, you risk something called mono-method bias, where your findings might just be an illusion created by the single method you chose to use. You really need both to understand what's truly going on.
And the proof is everywhere you look. You've got action researchers using highly quantitative meta-analyses to prove their impact. And at the same time, you've got traditional scientists using qualitative interviews to check their own biases and make sure their measurements are valid. So the bottom line is, great research uses the right tool for the job. Period.
So if these three great divides are really just big misunderstandings, what does that actually mean? Well, it means we're not looking at two warring factions here. We're looking at a family that's been separated and is really ready to be reunited. And you know what? The connection is way deeper than you might think.
This quote from Kurt Lewin, the guy who founded Action Research, it says it all. He wasn't anti-science. He was a scientist. He just believed that research had a moral duty to lead to action. His whole goal was to apply scientific principles to solve urgent social problems. He wanted to connect science and action, not drive them apart. And now for the final piece of the puzzle, the most compelling piece of evidence. This is proof that these methods aren't just compatible. They literally grew from the exact same intellectual root. It's a connection that's been kind of hidden in the footnotes of their most famous text all along. And here it is. This is incredible. The foundational textbooks on the scientific method, they trace its steps back to John Dewey's 1910 book, How We Think. Okay, the foundational text on action research? They cite the exact same source. They're literally branches of the same intellectual tree. They were never enemies. They're more like siblings who just took different paths in life. So, we end with this thought. For way too long, this false divide has kept these two powerful approaches apart. One side was told it was too detached from reality, and the other was told it wasn't rigorous enough. But what if we reunite them? What happens when we combine the power of rigorous, systematic inquiry with a deep, passionate commitment to practical, positive change? What are the complex, messy, real-world problems that we could finally begin to solve?